So hello everyone, welcome back to the Algo Daily. In this particular video, we are discussing count vowels string in a ranges for daily lead code challenge. So in this question, we have given a zero index array of a string words and 2D array of integer queries. For each query, we have given li and ri, and to ask to find the number of string present in a range of li and ri, and both are inclusive of a word that start and end with a vowel. So basically vowel is where we have present a, e, I, o, u. So we have finding uh, so we have finding to start and end with a vowel. Okay, so now let's deep dive into our question. So let's suppose this is our first example of a. Let's suppose here we have given a words of a, b, a, and okay, b, c, b, and e, c, e, and a, and e. Okay, so these are our words, and also we have given a query. So query is basically to the range, to the starting range and end with a range. So these are the query terms. So the words here we have count the words with start and end with a vowel. So here we have starting element of a is start with a vowel, so and end with a vowel. Okay, so the count of this is 1, and also we have find a cumulative sum of this. Cumulative sum is basically to find, if let's suppose this is 1, and to calculate all these elements and to count vice versa. Okay, so here start and end with a vowel, so count is equal to 1, and in next iteration we have getting b and b for starting and end. So b and b is here, so here is not presenting any vowel on start and end, so that's why the count is here 0, but we have finding cumulative sum. Cumulative sum is here, so now the cumulative sum of this is first is 1, 1 plus 0 is equal to 1. So next iteration we have getting e and e, so start with a vowel and end with a vowel. So the count is 1, but we have finding a cumulative sum, so that's why 1 plus 0 plus 1 is equal to 2. So the cumulative sum of this is 2, and in next iteration we have getting a and a is here, so the count is equal to 1 because of start with a vowel and end with a vowel, so the count is equal to 1, and the cumulative count of this is 3 because of 1, 2 and 3. And in next and final iteration we have getting here e. Okay, we have getting here e, so the count is equal to 1 because of start and end character is only here is e, so that's why the count is equal to 1, and the cumulative count of this is 1, 0, 1 plus 1, so the total is 4. So this is our cumulative count of this. So now we have given a query to run how many times we have getting starting and end character. So basically we have getting here the query of 0, 2, 1, 4 and 1 and 1. Okay, so now 0 and 2, first we have getting, let's suppose the cumulative sum of here is 1, 1, 2, 3 and 4, and here we have getting query is here 0, 2, 1, 4 and 1 Okay, so these are our queries. So now 0 to 2 is basically 0, 1, 2, 3 and 4. So the index value of 0 and the index value of 2, we have inclusive of these conditions, like 0 to 2 is basically 0 to 2. Okay, so now we have finding here to how many times are present, like in 0 to 2. Okay, 0 to 2 we have getting a prefix, like we have using here a prefix sum because of our time constraint, like 10 to the power 5. So we have using here to uh, prefix sum. Okay, so now we have using like 0 to 2 is basically we have getting a 2. Okay, in next iteration we have getting here 1 and 4. 1 and 4 is basically this to this. Okay, so this to this we have, if let one condition is here, let's suppose we have here is I comma j. Okay, prefix of I comma j. If prefix of I minus 1, let's suppose if I is equal to 0 minus 1, it is a negative range, it is a negative range. So we have neglect for this. So we have getting only here is 2, because of else we, if the negative is not coming back from here, so let's suppose this is 1, we have getting 1. So then we have calculating here 2 minus 1 is equal to 1. So then we use a prefix sum for this condition. Okay, so now here we cannot get any kind of positive sign for this, so that's why we only use only prefix of I. Okay, so now in next iteration we have here 1 comma 4. Okay, 1 comma 4 is basically 1 2 3 and 4. Okay, 1 to 4 is 1 2 3 and 4, this is our cumulative sum for this. So 1 to 4 we use a prefix sum for this. Okay, so we use a prefix sum of r plus 1 minus prefix of l. Okay, so prefix of r plus 1 is basically 4 minus prefix of l is 1, so the answer is equal to 3. Okay, so the answer is equal to 3. And in next iteration we have here 1 comma 1. Okay, 1 comma 1. 1 comma 1 is basically our range is only 1. 1 minus 1 is equal to 0. So the total answer is equal to, we have getting here 2 2 3 and 0. So uh, this is a simple approach. We have calculating all these vowels, and after vowels we have calculating a prefix sum for this. And now let's deep dive into a code and their time complexity of this question. Okay, so basically we have first we have calculating or we have defining a unordered set for vowels for a e I o u, and after this we have defining a prefix sum. Prefix sum is basically to store a cumulative sum of a count of the string that satisfy the condition. Okay, it satisfy the condition of start and end with a vowel up to the ith index. So that's why we are using this. And next we use a for loop for iterate through the string for the word characters, and after word vector, sorry, and after this we use this condition vowel dot count and vowel dot count for the front and the back, because we have finding only a first character of a vowel and end character of a vowel. Okay, that's why we are using front and the back. So basically the front, it is a front and this is a back. Front is basically to get the first character and back is to get last character. Okay, and next this is the condition we are using here. So prefix of, now this is prefix of I plus 1 is equal to prefix of I plus 1. So this condition is to update the prefix. Okay, it update the prefix. Update is basically to, if the string satisfy the condition, if the string is satisfied this condition, then we are increment the cumulative sum. We are incremented a cumulative sum for index I plus 1. Okay, in next uh, else condition we are using a carry forward. Here we are using a carry forward because of carry forward of cumulative sum, basically cumulative count. Okay, if the string does not satisfy the condition, we are carry forward the count from the previous index. Like if the index is here, then we are directly jump to the next element, because of, if the uh, like we using here, we are using here, like if we are not getting any character because of 0, we have here is 0, but we have already update their cumulative count, so that's why we are using here 1, because of cumulative count. Okay, so now we are getting, so now we are also defining an answer for our each query to store into an answer. So now we are here is query to L to R. L to R is basically to first and the second, first and the second, because of this first and the second. Okay, after this we are performing a prefix sum for this to calculate the range. So prefix of R plus 1, this R plus 1 is using, it gives a cumulative count of R, and it gives the prefix of L is basically to exclude the count before the L. Okay, okay, so count before the L, and after this we are using a difference between, sorry, L to R difference. Okay, so this is the simple approach uh, to find the range of the string. Okay, so now we are discussing here the time and space complexity for this. Okay, so the time complexity of this is this is O of n solution. Okay, and next we have given is this is O of n, and this is also O of q, and the total time complexity of this is O of n plus q. Okay, so this is the time complexity, and similarly we have calculating here the space complexity of this. So the space complexity of this is O of n plus 1. So we have only take O of n, and next we have here is O of answer, or we can say query. So the space complexity of this is O of n plus q is equal to O of n plus q basically. So the space and time complexity is same in this question. So now let's run this code. Now submit it. So now it works. So I hope you understand the logic behind this question. So thank you everyone.